Alright, good morning guys. Got two handouts I need y'all to number, please. So we're going to first look at the one that says properties of integration. It says that in the top right. If you would number that as 87. So there's nothing new on that, but I did think it was worth our time to spend, 5 or 6 minutes giving you some time to try each one of those and then going over each one of those just in case there's something that you have not picked up on, but again, it's supposed to be all stuff that you know. So the top 6 just kind of state the properties. You can really ignore that for a moment and go down to question 1. Question 1 gives you a couple statements and then ask you to work 4 parts, A, B, C, and D. So if you would, please try to answer 1A, 1B, 1C, and 1D real quick while I get this put up on the screen correctly. And then we can discuss those, and you can circle any of them that were not intuitive to you. Also today I'd like to do 1 practice FRQ, and then I'm going to give you some time to finish up the second half of the bookwork. If you remember, we did the first half together, so all of that should be completed, but there is no such thing as too much practice with use substitution, so sorry, it's taking me a minute to find that file. So.
Oh, you got it. Yes. Okay, yeah. Okay, yeah, this one I was probably like unsure of that. I thought I heard it for a second.
Is it okay? I thought it was okay. Totally.
Did you get them yourselves?
Okay, let's see what you guys think about the first question here. All right, so 1A, what did you get for that? Okay, good. If it's starting at 2 and ending at 2, it's not opening up at all to create any area, so anytime the bounds are the same, you should get 0. Somebody else, what about B?
-8.
Okay, and how do you know that?
because when you go when you switch the bounds, the answer switches signs.
Right. Integrating 1 to 5 is the opposite of integrating 5 to 1. So that's how you were supposed to apply that. Okay, somebody else for 1C.
-12.
Okay, so this 3 just makes it 3 times bigger. Sometimes you guys ask about that. I tend to just pull it out front. It's 3 times whatever the rest of that was. So 3 times -4, -12, good. And on the last one I got, well, what did y'all get? Okay, I agree. If you know how much area there is from 1 to 5, if you know how much area there is from 1 to 5, and you know how much there is from 1 to 2, you could take out how much area there was from 1 to 2 from how much area there is from 1 to 5, and then you're left with how much area there is from 2 to 5. So it was like 6, this one, take away that one. That's where the 10 came from. Okay, so just a quick explanation over all of those. Any of those you want to talk about a little bit more in detail? Okay, do the same thing for 2 then, please. Try the 4 parts of 2. Again, just go with your gut. You don't need to try to like read the limits up at the top or the properties at the top. Just go with what you think, and you can look over those a little bit if you feel like you need to. Okay, Spencer, what'd you get for 2A? Spencer, what'd you get?
2.
Okay, I agree with that. So this would be -2 times the area from 1 to 9 of f of x. So the area from 1 to 9 of f of x is -1. Multiply that by -2, and you should get +2. Sounds good? Somebody else want to volunteer for B? Go for it.
9.
Okay, I agree, 9. So more than one term, just do them separately. This was 5, this was 4, add them up, you end up with 9. Sounds good? C?
-6.
Okay, I also agree with that. 1 to 7, so you kind of have to think about how these pieces fit together. Again, maybe it's just my brain, but I like to think of it as area under a curve. If I know how much area there is from 1 to 9, I can take away or subtract how much area there was from 7 to 9, and that's how much area there would be from 1 to 7. Okay, and then in D, I got -2. Everybody agree with that one? Okay. All right, take a moment and try the 4 parts of 3, please. Again, there's nothing new in here. I'm just making sure that you guys are familiar with these, because if you aren't, you need to know them. So. All right, my answers for part 3, I think really all they're trying to test you with differently on question 3 is if those variable changes mess you up. So integrating, plugging in u into f versus plugging e into f, or x into f, would integrate differently. But then if you turn around and just plug numbers into it anyway, you're going to still end up with a numerical answer. So if the area from 1 to 2 of f of x is 5, then the area from 1 to 2 of f of u is going to be 5. Again, the integration would have u's in it instead of x's, but then if you turn around and plug in the same numbers into the same function, it's still going to evaluate to the same thing. Exact same thing, except multiply by the square root of 3, so 5 square root of 3. Okay, what about C? Somebody besides Grace, because I think she said this one last time. What'd you get for C?
-5.
-5, good. If 1 to 2 is 5, then 2 to 1 is opposite that. Okay, and then it looks like -5 again. Exact same thing, except there's a constant here. You're welcome to put the constant out here, negative whatever that was. Okay, you guys okay with those 4? So we can move on? Okay. So there's only 2 parts to 4, so go ahead and try those quickly. Okay, so for these two, I tried to make a little bit of a visual to help you try to visualize this. But if you know how much area there is from -1 to 1, that's 0. And you know how much area there is from -1 to 3, sometimes making a little visual like this helps you figure out what you should be looking at. If this area is 0, but this whole thing is 6, then the area from 1 to 3 must be 6. That gives you a little bit of a visual to see how those things are comparing. You don't have to do that, of course, but I think it makes it a little bit easier. All right, part B should have the same answer, because if you switch the bounds from 1 to 3, from 3 to 1, that makes it a -6, but then they tacked on another negative, so a -6. So you should have gotten 6 on both of those. Do you need me to go in more detail on either one of those? Okay, to start off question 5 then, how would I go about figuring out this one? 0 to 2 of f of x. This is f of x over here. Just what would the process be, and then I can do the work.
You would find what 0 to 2 is.
Okay, more specific. What's the A word I'm looking for?
The area under the curve.
Right, remember integration means area under the curve. So sometimes you may be told those values, sometimes you may need to go and seek them out yourself. This question A is wanting us to find out how much area there is from 0 to 2, from the function to the x-axis. So to me, that looks like a quarter circle, so 1/4 of pi r squared. This guy has a radius of 2. So the area from 0 to 2 should be pi. Almost. What did I not do?
It should be -5.
Right, if it's below the x-axis, remember you have to have you got to be paying attention. It has an area of pi, but because the area is below the x-axis, it's negative. Okay, If you would go ahead and try, let's split this up. There's a lot of these. Do B, C, and D. Try those three first. We'll check those, and then we can do the last two. And I think you probably want to do these in order. I think some of these earlier questions on this part can help you with the later questions, so you don't have to do all of it from scratch again if you're writing your work down nice. All right, Ben, can you tell us what you got for B?
I got 4.
Okay, I got the same thing. So again, this is just saying area from 2 to 6. So triangle, 1/2, base would be 4, height would be 2, 1/2 base times height should be 4. Above the x-axis, so positive. Okay, for part C, you would need the area from -4 to 2, so you're going to have to split that up over multiple parts. This was a triangle. 1/2 base times height gave me 1, but since the area is below the x-axis, that's -1. If I had figured out that this was -pi, personally I like to write it in here, then this is the same amount of area. I can just eyeball that and see it's got another quarter circle with the same radius, and I'm trying to get up to 2, so it looks like we should have -1 minus pi minus pi. -1 minus 2 pi is what we were aiming for there. Then if you wanted to know from -4 to 6, it would be the exact same stuff. That's where I think it helps if you label it, because you might need it again. -1 minus pi plus 4 should give you 3 minus 2 pi. Everybody's all right with that? I can go in more detail if I need to. Okay, then go ahead and give E and F a shot so we can move on. Now, of course, any of these that you struggled with or you missed, please circle them and try to look back at them a couple times before we get to your next test. Sometimes being comfortable with this gives you some options on how you can work questions. So. I assume y'all still need more time. Yes? Nobody needs more time? Okay. My answers, let me just tell you what the two answers are, and I can go over both of them if you need me to. But I got, since this was absolute value, I ended up with 5 plus 2 pi. It's also possible I have a mistake, because I did do this quickly today during first period, and I had another class then. So, and F, I got 7 minus 2 pi. Did y'all end up with both of those answers? Which one do you agree with or disagree with?
I didn't get either.
Okay.
I didn't get
Huh?
I got E, but I didn't get F.
Okay. Well, it doesn't matter. It sounds like we need to go over both anyway. So absolute value, remember that means everything's positive. So if it's above the x-axis, it's already positive. If it's below the x-axis, it's negative, but we're going to make it positive because of this. So from -4 to 6, well, honestly, this is the, you're going to be tempted to maybe do this, but I would be careful with that. I would say from -4 to 6, I have 1. Remember, I'm making everything positive. 2 pi and 4. So that's where I ended up with the 5 plus 2 pi. Anything that was negative needs to become positive. You can't simply just put a negative sign on part D because all the stuff below was being subtracted and the stuff above was being added. And just switching the sign doesn't, it just flip-flops it. It doesn't account for that. You need to do it manually. Okay, I probably know where your mistake is on part F. So let's talk about this part first. And this is very common too, so it's good that we did do this. The area from -4 to 6 of f of x, well, I did that right here. So this part, assuming we didn't have a mistake there, doesn't need to be redone. Then, typically what happens is, y'all see a +2, and so you do +2. Is that what y'all did? No? Okay. I'm seeing some yes and some no's. This 2, if this 2 had been outside of the integration, then yeah, that's what you would do. You were going to add 2 to whatever this integrates to. But this 2 is inside the integration, so you have to do his antiderivative and evaluate him from -4 to 6. So you have this part, you plug in 6 the first time, plug in -4 the second time, and I ended up with, oh, okay, this could be my fault. This could be my arithmetic here. This would be 23 and a -2 pi. Did anybody have that earlier? Yes, okay. So that was my mistake. Sorry. I did not subtract that -8. I just subtracted 8. So I'll put a star by that one to remember that I need to be more careful there when I go over that next week with the other class. Okay, again, before you put this one aside, while all this is fresh in your head, circle the questions you may want to look at again. Again, the properties are all typed up on the top there, so you might want to glance at those too. But if you felt pretty good about that, then you may not need to look at it again. But I may ask for homework points, so of course, please file it away in your binder accordingly. So that's supposed to be 87. Next up, we're going to do one FRQ from number 88. This is technically our test review for chapter 5, and I'm giving it to you quite a bit early here. Part of the reason why I want to give it to you early is that if you know you need to be doing more to prepare for the next test, you can work ahead if you know that's where you're at. But I would like us to discuss as a class the first FRQ. Okay, so it says a particle starting at the origin travels along the x-axis with this velocity for any time that the time is positive. Anytime a question has time involved, you can pretty much always assume you're not going to go backwards in time. Time's not going to be negative. So we have a point, the origin, we have the velocity function, and then they're going to ask us to do a bunch of stuff with this. So how I would like us to approach this FRQ today is I'm not going to give you full time to work it, but I want to give you about 30-45 seconds to think about what do you think the process should be, and then we'll go over it, and then you can either confirm or deny that that should be your process. So A wants us to find the position equation. So again, you don't have to do that. We can do it together on the board, but I want you to think about, given that information, what mathematical process would you do to try to find position? Again, just about 30 seconds to see if your gut instinct is correct. Okay, so what does your gut tell you? How do you go about finding this?
Take the antiderivative.
Okay. If you integrate velocity, you go back to position. So the thing that you can take the derivative of to get e to the t would be e to the t. The thing you can take the derivative of is 6. Would that be 6x or 6t?
6t.
Okay, how do you know that?
Because we're taking the interval in terms of t, and if it had been 6x, then we would have been 6x prime, the interval, yes.
Okay, yeah. So this is, I kind of have postponed on talking about this too much, but this dt, this is important because otherwise you don't know if this is negative 6x, negative 6t, negative 6q. This dt helps us know that t was the variable with that one. Okay, and then don't forget plus c, but we can do a little bit better than that because we have a point. Because we have this point, we can say when y is 0, t is 0. That allows us to figure out that c is negative 1, and the answer to part A would be e to the t minus 6t minus 1. That's the thing that would have a derivative of e to the t minus 6, and it goes to the point 0, 0. Of course, you're always welcome to plug it back in and make sure. So go ahead and copy the rest of that down. And then I'd like you to spend 30 seconds before I tell you how to do part B to see if you would do the same thing as me. Part B wants you to think about how would you find the acceleration function. Okay, so that one should be a pretty easy one. Acceleration is the derivative of velocity, and the derivative of this velocity function would just be e to the t. Now, do I need e to the t plus c?
No.
Right, you don't do plus c with derivatives. Remember last semester was all about derivatives, we didn't need plus c's. Plus c is when you integrate, because you don't know if there was a constant when you take the derivative. Alright, and that's all we need. So part C, when does the particle change directions? Again, I'm hesitating for about 30 seconds so you can think about it. Just think about what you think the process should be. Okay, so what you need to think about for this is if you would like to know when it's changing directions, you need to think about when velocity is negative, it's going left, and when velocity is positive, it's going right. So when velocity is 0, it might be changing directions. But you got to be careful because it could be going left, be 0, and then go back to being left. So we've got to see where velocity changes signs. So let's set velocity equal to 0. Technically, this is a calculator question, so I guess you could use your calculator to graph this or the equation solver or whatever, as long as you can do that. I'm just going to go ahead and do it algebraically and add the 6 over, take the natural log of both sides, bring the t down, and the natural log of b is just 1. So the only time that velocity is 0 is at the natural log of 6. Natural log of 6. So we can see what's going on around that. And again, this is calculator allowed, so I might at least want to think about natural log of 6 as a decimal. If you get your calculator to solve it, make sure you go to 3 decimal places like the AP exam expects. But it's about 1.792, so this is the only place it might be changing direction, because that's the only time velocity is 0. So I could try velocity at 2, and e squared minus 6 is positive. That's about 1.4. So does that mean it's going to the right or to the left? To the right. And then it's probably going left here so that we have some, I don't know, an interesting answer, but we could try 1. So e to the first minus 1 is about negative 3.3. All that I really care is that it's negative. When velocity is negative, it's going left. So our answer to C should be, when does it change direction? When t is, you could either say the exact answer, natural log of 6, or you can round to 3 decimal places. Always, always 3 decimal places. AP exam expects you to do 3 decimal places without telling you that. And our justification of y is, I would say something like when t is from 0 to 1.792, velocity is negative. And then when t is bigger than that, I guess it goes on forever, but then velocity is positive. So answer, justification. Velocity at that time is switching from negative to positive, so it's changing from left to right. Now again, this was just to help me organize my thoughts. So that one is a little more intensive. Any follow-up you'd like to ask about part C? Okay, then part D. Is the particle speeding up or slowing down at t equals 1? And what about at t equals 2? So how are we supposed to know if something's speeding up or slowing down?
Acceleration.
Okay, acceleration and something else.
Direction.
Okay, and how do we know direction?
With velocity.
With velocity. So, oops. You need to know the velocity and acceleration at time 1 and the velocity and acceleration at time 2. So we have both of these things. It's just a matter of plugging them in. Plugging in 1 into velocity gives me something negative. Plugging 2 into velocity, actually I think we did these two on the last question, but that's okay. Gives me something positive. So all that tells me is that at 1 second it's going to the left, and at 2 seconds it's going to the right. But it could be speeding up to the left, or it could be speeding up to the right, or it could be slowing down to the left or slowing down to the right. That's where acceleration is also needed. So we had the equation in part B. So acceleration is just e to the t. So e to the first is positive. E is about 2.71. And e squared also positive. So that's the legwork you have to do. So it looks like it's speeding up during one of these times and not during one of these times. What is it that we had to check for?
If they're like the same.
Right. If velocity and acceleration are the same signs, that's the justification. It is speeding up. Acceleration is positive. The rate of change towards the right is increasing. If velocity is positive, it's moving to the right. If both of those things are happening, it's speeding up towards the right. You shouldn't have to say towards the right or towards the left, but you do have to say speeding up, and because these two had the same signs. Whereas these two have different signs. So this one's going left, but his rate of change is increasing to the right. So that is slowing down. Slowing down would be the answer. The justification is A of 1 and V of 1 have different signs. One's positive, one's negative. Okay, and then to finish up, what is the total distance traveled by the particle in the first 5 seconds? So once again, think about what you think to do, and then I'll write it on the board. Okay, if you want to know how the distance has changed from 0 to 5, you should be integrating velocity. Integrating velocity keeps up with the change in the function below it. If you integrate acceleration, you get the change in velocity. If you integrate velocity, you get the change in position. And we want to know how much it travels over the first 5 seconds. So from 0 seconds to 5 seconds. But there's one other important piece here to get the right answer. So what's the keyword to part E that changes what I would throw in my calculator?
Total.
Right, total distance. So whether it's going left or down or right or up, I want it to always be adding. I need it to always add, and the math symbol for that is absolute value. So again, this was a calculator FRQ. You do not have to integrate anything with a absolute value sign by hand, because the AP exam doesn't expect you to do that, so I don't expect you to do that. I will tell you my calculator took about 10 seconds to think about it. That's hard for it to compute that. But to 3 decimal places, that's close to what we should say. But of course, always try to add units. So unfortunately, this doesn't say, but if we knew, we'll just say units, singular. I don't know if it's feet or miles or centimeters or whatever, but you need to include units if you can. So I don't think this is actually a real FRQ, but these parts of this FRQ often show up on real FRQs. So again, I think it's better to try to break that up into multiple pieces than looking at all of it in one day if possible. But is there any clarification you would like over this first FRQ? Okay, of course, any of that you know that you're going to need to revisit, probably circle it so that you remember what it is you need to look at. Okay, and again, you are certainly welcomed and encouraged to move forward on that as you have time. That's why I'm giving you that review early. But what I need you to do now with your class time is get some more use substitution practice. So this is a different binder number than the part 1. We did all of part 1 together, but now you guys have seen use substitution notes. We did 7 or 8 questions as guided practice on the board. You did 1 of each type in Khan Academy. So at this point, you probably don't need me to hold your hand as much. You probably just need me to help you when you get stuck. So to finish up class, there's 11 of those. So I would love if you could finish that in class because I don't intend for that to be your homework. But I guess if you don't finish that in class, you'll need to add that to your homework. So go ahead and start, and I'll come around and help out with the bookwork as you get stuck.
So I think we have to work out a next test. So in order to be ready for the next test, you need to read over the circuit. Should I spend my time going over this?
Well, anything that was on the last test is still fair game for the next test. So I would say anything that we've done since January that you don't feel comfortable with, especially if it was the type of question that showed up on the last test, and yes, I would try to get some more practice. Some of that's also going to show up on this test if you want to get it. It's in the 4 sheeted lines: area under curve, average value, green line sums, trapezoidal sums.
So maybe it's not too necessary to go over those.
I would say, I wouldn't worry about it at this point.
Okay,
But maybe when you get closer to the test, if you're unsure, you could do it.
yeah. Just as, okay.
So please try to finish up the bookwork in class if possible. For homework there, I'm asking that you review it real quick. Get yourself to think about it again over the weekend. There's 2 assignments I'm asking you to turn in the Google Classroom. One of them is that book assignment though, so you don't have that done yet, but you need to turn that in before next class. Let me make sure that that's in Google Classroom. It's not. I will create it right now. As you guys are working these, of course, there's only a few of these that are odd that you can check in the back of the book. If it's a definite integral with bounds, you could type the question in your calculator to check your answer. And on my website, I have all of these worked out. So you could pull up the question, jump to the end, and make sure you had the same answer as me to make sure it's okay.
So where's that number 15? Okay, I don't know how to get this to turn into 5x dx.
Okay, well, first off, you need to multiply the dx over first.
Yeah.
du is negative 2x dx. Still negative 2x.
True.
Okay. Write down what you want it to be right below that. Okay, so what can you multiply negative 2 by to get 5? It may help to do this. What can you multiply negative 2 by to get 5?
Oh,
Negative 5 halves.
that makes sense.
Yeah, and the negative 5 halves isn't something that you're just going to instinctively think of. That's why you need to do that process, because it makes it a little easier to miss.
Alright, thank you.
Doing okay? Can I help with
instead of going back.
You have anything I can help with?
When you get to
So it's just the
increase the
anti-review?
power by 1.
Oh,
That's
Can I help with anything?
don't, here, don't move on. Wait, what?
Okay, any questions I can help with?
Nothing that I can't like figure out like here. That's something that we can look at.
How to integrate that?
Yeah.
You can rewrite it as u to the negative 2.
That's what it was. That's what
And then you can undo the power law.
Yeah.
Looks like you're doing good.
Well, you could rewrite it this way if you wanted to. This is the same thing as this, is the same thing as this, the same thing as this. I don't know that you need to change that, but it is true that those are all the same, so I probably wouldn't do it unless I thought I had to.
Okay, again, I am here to try to help out. Use substitution's not the easiest thing, so and it's not going to get any easier if you're having troubles and you're not getting the help that you need. So keep in mind, I know I mentioned this before, but your next test is the only grade replacement opportunity we have this semester. So if you do better on your next test, it will go in as that test grade and it can replace your first test grade. And if I remember correctly, last year this test had like 5 or 6 use substitution questions. There's a lot of them on there, so that can certainly make or break you. So don't be dismissive. This is the most important thing we're doing all semester. Need to make sure you feel really good about the process. Okay, if y'all have something, please holler at me or bring it up here.
Yeah, I'm so far transfer. You might have never read it. I'm just writing the other questions.
What? You're way ahead of me. What? Why you do? muscles. Which doesn't necessarily help, I guess, but. Yeah, it's time to do something faster than helping, but honestly,
So I have to just go with that.
Looks weird. Yeah. It's on the bottom, so.
No, that's right.
Well,
So I can't get rid of that yet.
Yeah, I was like, that's fine.
you have to kind of do the,
Isn't it negative?
to get rid of it, so you would have to
5 over 2.
put the,
Because 2 over 5 would be 4 fifths.
well, you could start off by dividing by 2. Dividing this one's by 2. Okay. Oh, I think you're right, actually. I think you're right. Yeah, that's right. That makes sense.
Okay, guys. Just forgot Samuel. I'm really bad memory. Sorry, guys. I don't know Spencer. My brain you guys look all different. He has like glasses.
Yeah, this is your one shot.
And he has like a much softer. Yeah.
Hold on, what'd you get? 8. What? Oh, I just went back at the bottom.
I think it's one over you split the interval would be just one over you.
Yes.
If you have negative 2, you have negative 2. divide by -1, so it's -1 over u. And then we multiply that with 1 4, and it's -1 over 4 u. And not just
Oh, yeah, you're right.
yeah.
Can I say that this is trapped up there? The 7x?
It's trapped up there?
Like, you know how, like, you
Oh,
trap?
yeah. Yeah, U is probably 7x.
Okay, thank you.
Having trouble with 47.
Okay. What I would do for 57 is if you, or 47, if you split this fraction up into two parts, then you can do U substitution here, and the right one will reduce a little bit, and you may not even need U substitution.
Oh.
But yeah, you're gonna have to split it up into two parts.
Okay, thank you.
This is the same thing as theta to the -1. So if you take the derivative, you need to bring the power down, lower the power by 1. You use negative 1 over theta prime squared.
Why?
This one, you can't start out with U substitution yet, but you can split this into two fractions.
But I have to
You can do
multiply by
5 over this, and integrate that.
When you have to multiply that in times.
Yeah, it doesn't work out. You need to split it by the fraction. So 5 over the denominator, and outside is just the negative numerator, and just bring that two parts separately. Oh, it's not numerator and the denominator.
So for this one, the power goes to the
It's just
and 1 to 5x squared.
So I'm gonna get negative U. So the negative 1.
You have a fraction like this.
You guys said it so.
X on the 5, y is y. And for you, the negative is 20 is greater than parts. Because U substitution won't work otherwise. And that's gonna be big ones from
It's 7. U is 7.
she was like, okay, please put it out there. Please tell me what actually. I won't get back to her because it's not the main one. Send it to store and just try.
But how do you get the 2X up top?
You get 1/2 times the square root of 1 plus x.
Oh, okay. So u equals 1 over theta, and the derivative of 1 over theta is 1 over theta squared. Wait,
why is it 1 over theta squared?
cause like, that, the integral of this, the derivative of this.
Dude commented on my Hoso post from like, I just
Yeah, yeah.
random dude that and this is just
Oh, negative.
well it's just like it's just this car account.
And then going down.
it's really like
Substitute that.
Yeah.
that's so weird anyway.
You do.
And you get 5/2.
Slightly worrisome.
Strange.
I mean I have a public account so like
Yeah.
but it's still very random. And he doesn't even follow me either, so I don't know where in the world.
What is it?
It's a little strange.
Because d would be negative
You're not there.
e to the x over, this is negative, so it's just negative.
You were counting as 2 separate things.
And then you multiply.
Yeah, so you're gonna have to do like a
Yeah.
partial to introduction.
Come on. Negative? Oh, I don't
So, like, regarding track, you don't talk about actually helping you this was
How do you even think about that?
Putting with the natural log, and then Wait, I don't really know.
Not Anna.
I don't look at how it works, but like, you know when they replace
It's 0 minus 1 over.
See, this is why I can't get a 5 on it.
One over X.
I can pass, but this is so See, I was like, oh, I'll be able to figure it out. I don't know why I don't. This is more fun. That's so wrong.
Okay, Sam. What's your power of the U? Negative 1/3 plus. No, it's negative 1/3. Because it's on the bottom.
You did it wrong. He's so good.
What are you talking about?
What happened?
What's your grade in that?
I still can design a book list, that's not what
Brian's smart, right?
What? It's like,
You write it, it's like, so his name's we check the nice because I did these next. And don't forget this. Don't forget Massey. Yes. Mr. Johnson. I didn't.
One like Washington State. I would Washington. He wants to be here. I thought about Washington.
I wish I had
Well,
I already got
soon
to
come.
grade weight, so we're asking right now. Really good speech. Dang. Go, it comes out.
You, which question are you on?
I skipped it. I skipped the other one.
I don't know, where is the team?
Oh, God, whenever you get that, you tell me on that.
what?
I'm gonna watch it.
For 47.
Yeah.
I'm gonna watch it.
Yeah, alright.
Okay, good, thank you.
Are you on 47?
Well, right now, I'm sending you back.
Just
skip one.
I skipped 47 and 50, yeah.
Just set it equal. Set it right equal.
I get that.
And then you just divide by 2 and you plug it back in.
Wait, what?
For,
Yeah, okay. You said setting Yeah. Okay, okay. So that's what I have for 2x and 2. I'll rewrite that. And then I'm trying to-
Then you multiply, right?
You're trying to get that.
So it would be negative 2 theta 2 negative 1 theta.
Oh, I see what you're saying.
Yeah, dx is just that.
When you bring this down,
EX is just, okay, just list out the
Yeah, 2x2.
yeah, du equal to the exponent of the equals. Because you can't, it'll be easier for you to equal.
that's so good.
You want this right here, because you want to replace it. So you write it down here.
No, I do. Now, let me write a question. The word.
Yeah, because when x will equal so that and then plug it back in.
How does x equals 5 minus x?
Well, you need to figure that out. Because
I divide this by 2, those are going to equal each other.
because this is algebra. It's like
Where do you get
you're
x equals 5?
solving. You're solving for x. You want 2x to equal 5 minus equal to x.
Too easy?
You're solving for x. Stop the class, right?
Huh?
It's not that you want to replace it with like
Oh, that was not hard. Wait, is it negative
missing
1 over
something
2
important.
theta?
Did you check your answers?
I checked some of them.
Oh my god.
Okay.
I could check the
Well, I
right.
forgot that.
I mean, you have time.
But I'm pretty sure. Pretty confident.
Yeah. I forgot cosine. Oh, Samuel. Did you get negative, or negative 1 half sine of 1 over theta plus 3? What did you get for 43?
First minus 1/3.
3 over x minus x to the negative.
Duh.
So if I do 3,
Wait, what is it then? What should you be? You are.
Okay, since you wanted to make this
Okay. Would it be too bad?
Okay, yeah.
You're just not being useful.
Wait, even though it's 2x.
I think it's 5 minus 3x. I gotta. I think it's plus 5. Okay, just like 5 plus this whole thing.
And so, if you
In
do
order to make
that,
this 5.
it works out.
Hey.
It's gonna be.
But again, you don't have to know that at this point. I'll make sure that you know.
Oh.
That's the reason why you tend to use those.
Wait,
You didn't recognize this form.
Oh, so we're trying to get each of two
So multiply by 2, that's just it, right?
Well, we're trying to get one over.
Well, it's to the fourth here.
Oh.
And then 1 minus x to the fourth.
Well, you have to divide it, by 2.
Well, we get that far.
If you have, also, if you have that, or
I saw that
Just get
this
harder, so you
looked
can
like
do
this.
you have to like, it's only sequence, I like it, it's only that, that you have to.
Oh, okay.
Yeah.
Oh, and you could just do that if you wanted to.
I've seen that one.
It has to do with yeah.
For our class, we
So,
I like it.
but I've
Yes,
been
you
working
could factor
on
something like 1 minus x and 1 plus
with
1. X comes
two
through.
of my commentaries.
You say they're really cute sticks.
These values are designed to portray the consequences of right.
It's like,
And then my first.
Why are you splitting this by 2 parts? You can't do part of it on x and part of it on.
So I did.
the negative x,
You can split apart the
Particular
fractions, you can split apart the numerators, you can't split apart the denominators.
And my commentary.
Did it.
Shakespeare's Ulysses and Ophelia is to be played for
You can't just leave this where it's that denominator and just pretend like it's not on that part there.
But like, on display, I can't really.
Okay, I do your mind. But you can't all of a sudden say, oh, right, so all of this is integrated multiple times, integrated that. If you have this one right,
They're,
that could be your u,
and I
that's how
said,
you
they
can rewrite it.
to illustrate his grades with regard for
Yeah, you don't worry about it, but for this right now, so I should expect you to do something.
that, or being.
Oh, no, it's on there.
Sexuality in the Shakespeare's that represents these two
It's in the battery.
If you make a real simple problem like integrating two x, right, integrating 2, and then integrating x, try multiplying them together.
it's so good. I don't know, it's so perfect. Yeah, it's not very good.
Good for a person.
Dude, I think that you put it on your stuff.
Okay guys, y'all have about 4 minutes. If you have any of this homework you need to have done, I will see you again on Monday. So you need to make sure you take a snapshot, jot down what you need to do. There's a couple things supposed to go into Google Classroom, but you've got about 4 minutes. So if you still got my calculator, you could start bringing that back, please.